shot at prompt engineering and diving more into that in our LLM workflows. Great. So we're trying to make prompt engineering something that's both beginner-friendly and workflow-ready. One book that I would really highly recommend, I'm still in the process of reading it, but AI Engineering by Chip Quinn is really great for breaking down what makes AI tick and how you can maximize your usage of AI in a way that's both effective and controlled. So the chapter that I'll be referring to often in this presentation is the prompt engineering chapter. Really great stuff for even if you're not a developer or if you're a super experienced developer, this book is really great. What exactly is the goal that we're looking at here? The goal is what we want as an outcome of the age of AI. So we want results that are reliable. We want results that are consistent. We want them digestible, evidence-based. But how do we get those results? Prompt engineering is a method for us to tweak the model without actually tweaking any of the code behind it. In Chip Quinn's words, prompting is the easiest and most common model adaptation technique. That means that whatever situation that you are in, the way you are prompting or asking your LLM to perform a task is how you can manipulate the results to be what exactly you demand from the model itself. What defines a reliable output? Whenever we want an output from an LLM model, whether that just be in general or within a Diffy workload, we want outputs that are repeatable, grounded, and structured. Repeatable means that with the same inputs, you are returned the same style of output and same structure. That allows you to take whatever output you have and use it in a future, maybe a future node in our workflow, or just extract it to wherever you want to put it outside of Diffy or in your daily lives. Next is grounded. The output should only be based on input text and evidence provided. We'll expand a little bit more on this later on in the presentation, but AI models have much data backing it. However, depending on the situation that you are in, you want the AI models to use the information that you have to make a grounded decision. Say you are an HR specialist. If you are using information from the web to dissect whether a resume is good or not, that may be unreliable because it's not information from the resume. You're not taking evidence from the context that you have. So we'll dive a little deeper into that when we get more specifically into prompting. But the last thing is structured. We want to make sure that the result of our LLM has no vague words, and the results are readable in either by human or by machine. Now I want to dive a little bit into prompt anatomy. What exactly goes into the prompt that we send to an LLM? The anatomy of a prompt has three main parts: the task description, the examples, and the task/context. Task description is the main part of the prompt. It describes what the model should do, what role it should act as, and what the output should look like. Some people also opt to add in a persona to meet these requirements. A persona is just telling the model what viewpoints to adopt. For example, if you tell the persona you are a careful evaluator versus you are a software engineer recruiter looking for specific skill set amongst your candidates, or you are a strict reviewer, any of these personas can be adapted by the LLM to better fit what you want as a result. It changes how the model makes trade-offs, whether it's strict on certain requirements or flexible, and detailed versus fast. The second part of the anatomy of a prompt are the examples. This is typically optional. However, examples do help determine what exactly is a good answer from an LLM. This is especially important when tasks can get very confusing. Example, if you are an HR specialist and you just are using an LLM to look through this resume specifically for one skill set. It is really helpful if you offer a good answer to be like, oh, a good answer could be, this person has experience in this project with Python, Java, and C++. So they are fitting these requirements. However, they do not fit these other requirements. This helps when the LLM is dealing with a lot of different types of information. It helps organize the answer into something that you actually want. The last part of the anatomy of a prompt is the task and context. As I mentioned before, the actual input of the model must be something that they can work on. So whether that be like the document you're looking at, the email, the ticket, the resume, the policy, all of these things are things that the LLM can use to determine their outcome that they're going to return to you. Without the proper context, there's a chance that the LLM will not return the output that you want just because it doesn't fully understand the situation at hand. So let's take a deeper look into how we distinguish these three parts of the prompts into our Diffy workflows. So we're going to take a look at the two layers of LLM prompting, system prompts versus user prompts. The system prompt is basically the model's permanent instruction manual. It decides how the model should behave in every time you run the model, no matter what input it receives. So what should go here includes the model's role, its persona, the scoring rubric that you want to look at, non-negotiable constraints, formatting requirements, all of the things that are reusable across many iterations of your LLM is what you should keep in the system. So whatever is consistent and reliable in your use case. The second part is the user prompt. The user prompt contains the context of the model that we should work on at the time. Earlier, I showed you a workflow very briefly that iterates through batches of resumes. So it takes one resume at a time, looks at that resume, evaluates the candidate, and then goes back to take another resume and do the same thing. What would go in the user prompt is the new resumes every single time that it's being screened. The actual input text is what goes into the user prompt. This user prompt is essentially the data, and it varies by person, by case, or per batch. Some other helpful information to take a note at while prompting in AI workflows include token cost and efficiency. So what exactly are tokens? Tokens are pieces of text that the AI reads or writes. This can be short words, which are usually one token, or longer words, which are usually multiple. Even punctuation and spaces count for these tokens. And why does this matter to you? You pay for input tokens, what you send to the LLM, and output tokens, what the LLM generates. More tokens equals more costs and slower responses. So it's a bit of a trade-off between how thorough you want your prompt to be. If you have very specific instructions, it'll be probably more costly than if your instructions were very vague. What is most important to keep in mind to keep these efficient is keep your prompts short but clear. If you have a lot of requirements, it is okay to use up more tokens to make sure you emphasize those requirements. However, you want to make things concise in order to reduce the cost overall. Let's remove any unnecessary text. If you are reiterating things for emphasis, that is fine, especially if it's the key rules at the beginning and end, but do keep in mind that tokens are being tracked every time you are using more words in your prompts. The rule of thumb with prompting is to be clear, to be explicit, and to always back with evidence. These three things will help you figure out what prompt is best for your situation and also reduce the cost overall. The most important part here, in my opinion, is backed with evidence. Context prevents hallucinations. So what exactly do we define as a hallucination? A hallucination is a confident piece of information the LLM generates that was not in the input. For example, if you inputted like Shani's resume and the LLM extracts data from its database that says, this project that Shani has never worked on is useful for this resume. Without the context of just focusing on my resume, the model can hallucinate and it tries to make up for the lack of information with facts that are not necessarily applicable in that circumstance. So context defines exactly what a good resume means. So the rubric, the real input text, and everything that you have in your prompt are great contexts for making sure that everything is backed with evidence. Some more advanced knowledge that might also be helpful are workflow-ready outputs, iterations, and customization. So a JSON is a structured output that computers can read. In the case of iterating through resumes, that can be like the decision of whether or not a person is accepted, the evidence behind it, their scoring for their resume. This is all information that you can imagine, we might need to feed somewhere else. which is why we want to output it in JSON format so that another machine is capable of reading it. The schema is the blueprint for JSON. For example, the decisions must be one of accept, maybe, or reject. Scores must be 1 to 10, and evidence must be a list. This is all information that's not necessarily completely needed at this time, depending on your level of knowledge of LLMs, but it is great to keep in mind that you are able to structure the output of like an LLM node in your Diffy workflow and use it later on in a way that is more applicable and more efficient. And I can show you a little hint in the later workflow that we're going to work at.